Hello, welcome or welcome back to my channel. My name is Fran, and today I would like to talk about a theory that appears to reconcile the two most fundamental theories about reality at present: Einstein's general theory of relativity and Bohr's quantum mechanics. Now, both theories have been tested time and time again over the course of the years, and they've both stood the test of time, working perfectly well for applications such as, in the case of relativity, the development of GPS, or in the case of quantum physics, transistors, lasers, quantum computers, smartphones, entanglement of larger and larger molecules, etc., etc. Yet, as successful as these two theories have been over the years for the development of technological tools, we have a problem. You see, the general theory of relativity works exceptionally well for macroscopic systems, in other words, large objects, the physical reality with which you interact on a daily basis, while quantum physics works incredibly well for describing microscopic systems such as subatomic particles. However, the two theories are at loggerheads, and they have been for roughly a century now. Both theories simply cannot be true or valid. You see, at the beginning, it was postulated that there were simply two different realities, one macroscopic and one microscopic. Yet, this conclusion was untenable in the long run. First of all, there was a problem of the cutoff point between what is part of the microscopic and what is part of the macroscopic world. Where do we draw the line? When does a system cease to be microscopic and becomes macroscopic? Also, are we not made of the same microscopic stuff, such as, subatomic particles? Of course we are. So in the end, we had to let go of this split personality disorder that affected science and embrace the fact that neither theory, as presented, could possibly be the complete description of reality. Something was amiss. For instance, Einstein, in his theory of relativity, had established that light travels at a constant speed, and nothing, even information, can ever travel faster than the speed of light, which was set as something like 300,000 kilometers per second. Yet, according to quantum physics, entangled particles could exchange information simultaneously, or even when separated by massive distances in space. In other words, they could exchange information without any time lapse, or to say differently, faster than the speed of light. Now, Einstein could not accept this, and together with Podolsky and Rosen in the famous EPR paradox thought experiment, he challenged Bohr and came to the conclusion that since no information can travel faster than the speed of light, then quantum mechanics could not be the complete theory of how reality works. There must be a hidden variable somewhere that makes it seem like the two entangled particles are communicating instantaneously, but in actual facts, they are not. Maybe they postulated the two particles were set up with definite features from the start. We just didn't know what they were. But experiment after experiment, it was proven beyond reasonable doubt that entanglement and instantaneous communication across space was a real thing. In other words, once entangled or linked in some specific way, two particles can travel all the way to opposite sides of the universe, say, to a different galaxy, but upon observing one, you collapse the state of the other, as if the two particles could exchange information instantaneously at superluminous speed. Now, many scientists over the years have tried desperately to reconcile general relativity and quantum mechanics to no avail. Bell's theorem seemed to be the final nail in the coffin for general relativity, as it proved mathematically that entanglement is indeed real, and that observation collapses reality in a way that forces the observed particle and its counterpart into a definite state simultaneously. Bell's theorem showed that there were no hidden variables. Observation collapses reality simultaneously for particles at the opposite ends of the galaxy or of the universe, for instance. Although Einstein himself had introduced the concept of the relativity of time and space, time dilation and space contractions are consequences of the speed at which the observer is moving relative to the observed object. Quantum physics was now saying that particles or objects or information could move from A to B without crossing the space in between. In actual facts, it wasn't so much that information traveled faster than the speed of light, rather that it didn't travel in the traditional sense. Space-time itself was, in other words, an illusion. While Einstein understood that time and space were not absolute, but relative to the observer, and thus different from different observers moving at different speeds, he still maintained that they were real. Quantum physics takes the relativity introduced by Einstein a step further by stating that particles don't travel smoothly across space. They're not really localized anywhere, and therefore they're nowhere or even everywhere at once until observed. So space as a real entity begins to collapse in on itself. Then we have the issue of time. You see, at the quantum level, there is no past or future. There is no arrow of time. The laws of physics are completely and utterly time reversible. An electron is the same thing as a positron traveling backwards in time. There is no way to know which is the past and which is the future. Now you might ask, how is it that in our everyday life we remember the past but not the future? According to Dr. Lanza and his theory of biocentrism, the answer is in the question. The clue is in the word remember. Memory requires a conscious observer. If you observe something, you collapse its wave function, making it real. Once you have observed something, you record this observation, this information in your mind. It becomes a memory, and as such, it cannot be uncollapsed. Yet, at the quantum level, experiments such as the delayed choice quantum eraser have shown that if you introduce the observer, but in this case not a conscious observer but a sensor, after the particle has already spread out like a wave and traveled all paths simultaneously, it can be observed retroactively and collapse, therefore making it appear here or there with a 50-50 chance at random. So, at the quantum level, particles can travel backwards in time and change reality retroactively, even if already observed by a detector. So how comes this is impossible in real life? According to Dr. Lanza and his biocentric theory, what makes space and time real at all is consciousness, the mind of the observer. Memory is the property of a conscious observer. Even the result of an experiment is not final until measured by a conscious observer. Although a detector can make an observation or take a measurement, such an observation can be uncollapsed or time reversed until perceived by a conscious observer, capable of making memories, capable of making sense of the findings. According to biocentrism, time and space are not merely subjective to the observer, they are only existing in the mind of the observer. Hence why they do not exist at the subatomic level. Then you might ask why, and also why they're slightly different for different observers. So once you take into account the conscious observer, all quantum witness disappears and general relativity makes sense, finally. Time and space are relative to the observer because they are observer created. Biocentrism also resolves another sticking point for classical science. When you take into account the parameters that made conscious life possible at all, the weak and the strong nuclear forces, electromagnetism, gravity, etc., they all seem to have been fine-tuned perfectly to allow for our creation, for our existence, for the existence of a conscious observer. Now, a tiny change in any one of some 22 parameters would destroy life as we know it by making atoms collapsing on themselves, for instance, or their particles disintegrate and fly off in different directions, etc., etc. So we are either an incredibly unlikely coincidence, a freak accident of nature, which by chance happened to create this conscious observer, this conscious being able to observe itself, or we are the result of an intelligent design. And by intelligent design, I mean an external God outside of the known universe who has created us. But the question still would remain, who created this external God? So that's not really an explanation as such. So neither of these explanations are obviously satisfactory. On the other hand, the fact that the universe is perfectly fine-tuned to allow for the existence of a conscious observer is absolutely consistent with the biocentric theory of the universe, or multiverse more likely. Think about it. If it's consciousness which creates the universe and not the other way around, then we would have created a universe compatible with our existence in it, obviously. The universe has not allowed for our existence in it. It's the other way around. Our consciousness has imagined the universe into existence. Now, I know what you're thinking. Evolutionary theorists will counter this with the fact that the universe existed billions of years before we ever came onto the scene. But, number one, here we would have to define what a conscious observer is. Is it a biological being capable of interacting with the environment around it enough to collapse reality? Secondly, as we have seen in the quantum erasure experiment, at the quantum level, time has no arrow. Events can be time reverted until collapsed by a conscious observer. In other words, consciousness doesn't know past or future. It only observes in the present a universe consistent with its own existence. Now you might ask, how comes if the solid reality that we see out there is an illusion created by the mind? Time, space, etc. don't actually exist in absolute terms. Matter is collapsed by observation and so on and so forth. How comes reality is stable and everyone more or less agrees with the same version of reality? Now, there are two levels of explanations for this question too. We could say that by sharing information with one another, we collapse each other's wave function of reality, thus forming a consensus reality. On a deeper level, we can take the illusory nature of space-time a step further and say that if time and space, which feel so incredibly real and absolute at the experiential level, have been proven beyond reasonable doubt by quantum physics to be only existing in the mind of the observer, then what's to say that the rest of reality is not the same? What if the whole universe is a construction of consciousness designed to explore itself? What if others are simply a mirror of a part of our own consciousness? What if the separation that we experience in our physical world is yet another illusion or hallucination of the mind? You see, consensus reality may simply be the consequence of the fact that separation is yet another illusion. When you take into account all these considerations, the crazy ramblings of a 1940s mystic named Neville Goddard don't seem like such ramblings anymore, do they? When Neville Goddard said, "Everyone is you pushed out," maybe that's what he meant. Biocentrism can reconcile perfectly quantum physics and relativity, because if separation is merely a tool used or created by the mind, then information does not travel faster than the speed of light. It doesn't travel at all. Information is everywhere at once, and it simply collapses when observed. If space is an illusion, as demonstrated by entanglement, then so is separation, because think about it. What is separation if not the intervening space between here and there? And if there is no separation, then there cannot be me and you. It can only ever be a single consciousness which has imagined itself as separated. You see, Lanza states that if you keep observing the same quantity over and over again, keeping in mind the result of the first measurement, you will see a similar outcome. Similarly, if you learn from somebody about the outcome of their measurement of a physical quantity, your measurement and those of other observers will influence each other, freezing the reality according to that consensus. In other words, consensus about the nature of reality defines its very form. When Einstein stated that imagination is more important than knowledge, he was onto something, because knowledge refers to the already observed, already collapsed reality, while imagination can collapse a new wave function, a new possibility into existence. So to sum up, there is only one way to reconcile quantum mechanics and relativity, and it's by accepting the role of the conscious observer in the creation of reality. If consciousness creates reality, then space and time are just tools of the mind to make sense of separation. At the quantum level, we are all one. There is no separation, and therefore it makes no sense to speak of distance and time. Time only makes sense in the context of memory and perception. Cause and effect only makes sense in the mind of the observer because one needs to occur before the other. As we construct a sequence of events in our mind, as we build a story of what happened in our mind. Finally, biocentrism reconciles creationists and evolutionary theorists by stating that we were not created by an intelligent design, and by intelligent design, I mean an external God, nor were we the result of a freakish coincidence, which made all the variables in the universe just right, just perfect for us to exist within it. Consciousness observed itself into existence, and in doing so also created a universe compatible with it. In other words, consciousness created the universe, not the other way around, but not an external consciousness, some otherworldly God. No, it's the same consciousness which has split itself up into many observers in order to observe itself from different perspectives. Our mind is part of this universal consciousness. It works as a feedback mechanism. It observes, and while observing, the way it observes, the question it asks, they are not meaningless. They are all tools to construct reality, to imagine reality into existence. So how we decide to observe the world is significant, as it shapes the actual structure of reality. The challenge here is to not be overly affected by past observations, if that is not what we want to observe and reproduce in the future. What we look for will affect what we find. So imagination is more important than knowledge, because from knowledge and memory, you can only ever recreate the past. Through imagination, you can expand and create something new. So the way we choose to observe reality doesn't merely affect how we feel about what we observe in the present, but rather what we will observe in the future. And the way we choose to observe the past will also affect the present and future reality in a very real, very physical sense. The information we process and the way in which we process it does matter. It actually shapes the reality that we experience on a daily basis, on the physical plane. So this is it for today. If you are interested, I might do a podcast more specifically on the EPR paradox and on John Bell's theorem. In the meantime, I intend that you find this content useful and helpful in shaping more deliberately and more consciously your everyday reality. And if so, please remember to like, share, subscribe, and hit the bell option to be notified of my future podcasts. In any case, thank you for listening. Have a magical, conscious, awakened life.